Hey kids. Hey kids. Hey. Okay. Here's my disclaimer. Don't cheat. Don't copy. Don't come here just for the answers. It's dumb and stupid at the same time. So, if you've already taken the time to go through these problems and try them on your own and you're stuck, go ahead, play the video. Please play the video. If, however, you are here to subvert or to get around doing your homework because you are lazy, hit the stop button, close the window, go do your homework. I don't want you around. If you like what you see, hit subscribe button. I got lots of videos coming, but I'm going to give you this disclaimer every single time. The Algebra 2 Trig 2 Algebra 2 Trig test assessment at the end of the year is not bad. It's not easy, but it's not bad. But if you cheat and copy and use these videos for their unintended purposes, you are wasting your time. You will not pass the Regents. You may pass the class. Who cares? You need to learn math, not just pass a class. So, here we go. Enough lectures. Hey! Look, kids. All right. At this point in your life, you should recognize these two things as conjugates. Conjugates means they're the exact same parentheses. One's plus, one's minus. If you recognize that they're conjugates, it makes your life easier when you're going to try to find the product. Because you don't have to do the entire double distributing or FOIL or whatever your teacher calls it. All you have to do is 3 times 3, which is 9. My pen's not working very well. And positive square root of 5 times a negative square root of 5 is just negative 5. Boy, it is not working good. So that gives me 4. My answer is 4. I'm going to be looking over here to make sure I get these right. Okay, what is the radian measure whose measure is negative 420 degrees? That's some craziness. So we're going to take negative 420. Might have to reboot the old computer after this video. Times. Now to convert from degrees to radians, you're going to multiply by pi over 180. So grab the calculator. Oops, got all my other stuff from my last video in this. Let's get rid of all that stuff, so we don't want that stuff. And we got negative 420 divided by 180. And that will give us our fraction that we want. Negative 7 over 3. Negative 7 over 3. Oops. Negative 7 over 3. So this actually turns out to be equal to negative 7 pi over 3. Choice 1. Moving on. What are the domain and range? Now, so you have to remember that domain, I put in somewhere, domain are the x or the left and right values. So domain has a leftmost value of negative 4, it looks like, and a rightmost value of, well, look, it goes forever and ever and ever. So its x is greater than negative 4. And since it's got a dot, it can be equal to that. And that's not it. And these don't even have 4. So really, I'm done. X is greater than or equal to negative 4. But it's also, the range value is from 2, and it goes up forever and ever and ever, so it's greater than or equal to 2. Y is greater than or equal to 2. Done. Problem over. All right, so let's see what we got. Oh, my goodness. What do we have? The expression blah is equivalent to. Okay, so just a reminder of, if your teachers taught you this I circle, I'm going to show you 2 different ways to do this problem. We're going to do I to the first is equal to I. Now, if this, I'm only teaching this because sometimes this pops up as a part 2 question. And you need to understand a little bit about i's. Otherwise, you're not going to be able to just do them. Then I'll show you how to use the calculator. So I squared is equal to negative 1. I cubed is equal to negative I. And really you just have to remember this one and this one, because that is the opposite. And over here will be the opposite. I to the 4th is equal to 1. So if I know that, I squared is negative 1. That's just 2 times negative 1. Plus 3 times, well, I cubed is right here. It's negative I. So really what I have here is negative 2 minus 3i. So my answer is choice 1. Now, having said that and gone through that, I'm just going to check my answers, make sure I don't make any dumb mistakes, because I'm used to making dumb mistakes. And if you're in my class, every once in a while I'll make a dumb mistake. Okay, so I'm going to use my calculator. And the original problem was 2, and here's I, right here, I squared, plus 3, let's go back and find I cubed. And I'll bet if I press enter, oh, look at that, -2 minus 3i. It'll give me the answer. You just know how to use you have to know how to use your technology. I'm not sure if that I button is on the 84s. It is on the Inspires. And you are allowed to use the Inspires on the Regents exam. Don't let your teachers tell you you can't use Inspires on your Regents exam. So if you have an Inspire or want an Inspire, or don't have an Inspire, get one. They're not that expensive. Coterminal means they have the same ending value as -70. So what I'm going to do over here, off to the right, is I'm going to graph an angle of -70 degrees. Well, negative just means we're coming in this direction. Now, I'm not going to get to 90, so there is my angle that's -70 degrees. So all I got to do then is find the one that ends here. And it will be coterminal, and that would be choice 4. Right? Yeah. All right. What are the two possible values? So, blah, 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 we got a triangle plus 2 possible values. You had better know this is the law of sines. A, B, C. Anytime you're talking about how many triangles this and how many triangles that, we're talking about the law of sines. So, A is 74. And B, let's see, 59. Oh, they decide, oh, we got to add decimals to make things really complicated. The only thing decimals are going to make you do is screw up dumb stuff. So don't screw up dumb stuff. So our goal is to find angle C. Angle C. So we're going to do the law of sines. And if you remember correctly, that's A over sine A equals B over sine B. Blah, 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 equals C over sine C. Not something you have to memorize. It will be on your formula sheet. Right there, law of sines. There it is. It will be on your formula sheet, so you don't have to memorize it. You just have to know when to use it. Key is when to use it. Law of sines. Okay, so what we're going to do is we're going to take this 59.2 and we're going to divide by its opposite. The angle that goes with it, which is opposite, it's 74, is equal to 60.3 divided by sine of C. We're going to take the old big X. You can only take the big X cross multiplying across an equal sign. Everybody wants to cross multiply everything. It's sort of annoying. You know how annoying kids are? Just kidding, man. I'm just kidding. No, you're really annoying, actually. But that's okay. So are teachers. Why did I just write sine? See, all you kids annoyed me so much, I started to go through the law of sines and write cosine. Sine of C. Oh, I know why. Because it was C. Sine of C. I need more coffee. Hold on. When I drink and make mistakes, I need more coffee. My Bruegger's Bagels coffee in order to make sure I don't make mistakes. Yes, little ad placement. Bruegger's, how about some cash, kid? Nothing like a hot caffeinated coffee. It's really just the caffeine. Oh, I'm sorry, Bruegger's. It's the taste. Let's cross multiply. 60.3 times sine of 74. 60.3 times sine of 74. We'll get C by itself. 59.2. I've got a trivia question for you, kids. Here it is. It's a very simple one. If you're going to look for an angle, at any point it says, what is this angle? Well, how big is this angle? How many degrees is this angle? Round this answer to the nearest. And you're looking for an angle. You know you're going to have to do, pause it if you don't know, think, inverse trig. Inverse cosine, inverse sine, inverse tangent. In this case, it's going to be inverse cosine. So first thing I want to do is put this mess into my calculator, and then I'm going to inverse sine it. So I'm going to use my cheat sheet over here. It was, let's do control division, 60.3 times sine of 74 all over that 59.2. Now, 0.979. Oh my gosh. It's a good thing they didn't give me that answer. So then I'm going to inverse sine this crap. I'm not typing that stuff in. I'm going to hit the up arrow. Bam. There it is. 78.27. So C could be 78.27. Or I can do 180 minus this thing. Well, 78.27 is 78.3, so it's one of these. And then what I got to do is take 180 and minus 78.27. I think you can see that it's going to clearly be this answer, not the other one. Woo-wee! Yay! Moving on. 7. Uh-oh. Now, there's a question we don't ask much. All right, so here's how this works. You know how we just came up with that decimal, blah, 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 and then we did the inverse of it? So what this means, and you guys don't even know what I just wrote there. What this thing here says, all of this, is what it's saying is the cosine of what angle of some theta has to give me negative radical 3 over 2. Because if I was to go solve this, if I'm going to solve this, wouldn't I have to kind of like bring this cosine over here and get theta equals cosine negative 1 of the square root of 3 over 2, the negative square root of 3? So really what they're saying is what angle do I have that's going to give me negative radical 3 over 2? So what you have to remember, kids, is this. Cosine is of theta. Theta, if it's going to equal radical 3 over 2, that's a reference angle of 30 degrees. Memorize it. By now you should have that memorized. But I'm in the negative quadrants, and the negative quadrants for cosine are in the second or third quadrant. So first of all, not going to be in the fourth quadrant, not going to be in the second quadrant. It has to be one of these two. A reference angle of 30 degrees would mean we are at 150. Oh, I haven't been checking my answers. 150. Good. We're in good shape. Okay. Seen these problems a million times. You guys should be getting good at them. You notice that we do not have the same base. In order to solve these equations, you have to have the same base. Now, the base is either going to be 2, 3, or 5. Every once in a crazy great while, it's 7. Never seen it on a Regents exam. Never seen a 5 on a Regents exam. I've really only seen 2 and 3. Maybe, just maybe this year they'll put a 5. You'll know it's a 5 when it ends in a 0 or a 5. Kind of simple, huh? But generally it's going to be 2 or 3. Now let's see. 9. 2 to the what gives me 9? Stupid! Duh! Can't tell you how many kids, I don't know what the base is going to be because it's 9. I don't know. It's 3. It's either going to be 2 or 3. It's 3 squared. I didn't call you stupid, by the way. Don't you dare think I called you stupid. Not feeling the love here, kid. Not feeling the love. I don't call students stupid. Well, I do have a couple of kids this year that every once in a while, in my brain, I say, oh my God, nobody could be that stupid. And then they surprise me by being even dumber. And then pass the test, which is nice. Nice. So, 3 squared is 9. 3 cubed is 27. Now that the bases are the same, we're going to take the exponents and set them equal to each other. You know how people get we've got to distribute. So we're going to get 6x plus 2 equals 3x plus 6. One of the things I'm going to try to share with you is a way to solve these problems a couple of different ways. So I'm going to bring the 3x over to this side, I get 3x. I'm going to bring the 2 over to this side, I get 4, and I get x equals 4/3. Fantastic. So I'm going to use my calculator to cheat. So the problem was, we decided the answer was 4/3. Let me get rid of all this crap. I like having a fresh screen. So we decided the answer was 4. So 4, I don't know what I just did. 4 divided by 3. I'm going to store this into x. So right now, x is a 4/3. If I ever touch x, hit x, it's 4/3. So I'm going to type in the original. The original was 9 raised to the 3x plus 1. 3x plus 1. And with that, I get, 59,049. 049. I've been doing this too long. Now we're going to try 27. 27 raised to the x plus 2. X plus 2. And if I did it correctly, I get the exact same answer. Bam! Now, so you could have cheated. All you could do, one of your test-taking strategies is to start at the end, start with the answers, use the stow feature on your calculator. There is a stow feature on the 84s as well as these Inspires. So if you have an 84, you certainly could do that as well. stow it, and just check your answers. All right, kids, we got the quadratic formula here. You know it's the, whoa, maybe we don't have the quadratic formula. I was going to say we know because we saw all this craziness. But maybe it's factorable. So, let me teach you about factorable or not factorable. I'm going to show you something on the TI Inspire that will tell you if these are the answers or not. And if these are the answers, I'm done. So let's check this out. You guys, without Inspire, is going to be mad. So if you don't have one, you might want to get one. So let me clear out of all this stuff so I don't do anybody else's garbage. And what I'm going to do is I'm going to go into Menu. I'm going to go into Algebra. Polynomials is what I'm working with, and I want to find roots. It's a second degree polynomial. And the A, B's, and C's were 2, 7, and -3. So 2, 7, 2, 7, and -3. I hit enter, or I hit OK, and it says, is this it? 2x squared plus 7x minus 3, and we're solving for x? Yes, as a matter of fact, it is. Oh my gosh, look at those answers. Ugly. Not factorable. So we've just eliminated 2 choices as our answers. They can't be our answers. So we know it's not 1 and 2. Now, watch this. Our formula for the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Test-taking strategies. I want -b. Well, b right now is 7. -b would be -7. Here is our answer. And I'm not going to finish the quadratic formula. That's it. That's some test-taking strategies for you. All right, so what do you have to know about this? We got cosecant A. Bam. Cosecant A is really just 1 over sine of A, or it is the reciprocal of sine. That's what I'm going to remember. So, sine is opposite over hypotenuse. So I know that the sine of A is 7 over 25. Therefore, the cosecant is the reciprocal of that, 25 over 7. Choice 2. Man, we're moving on up to the top. I don't know what page I'm going. Looks like I'm going to page 5. Yeah. I'm an amazing singer. Thank you very much. All right, kids. Let's talk about some things. Let's talk about negative exponents for a second. Negative exponents have nothing to do with being negative. For example, and we're going to talk about this all the time because for some reason everybody thinks this is like -1 over x cubed. I don't know what it is. You get all crazy. Here's what it's equal to. It's equal to 1 over something. Turns it into a fraction. It's going to drop this into the denominator. It becomes x to the positive 3. Because really what a negative exponent is taking the reciprocal of this. If I had, for example, x to the -5, this would be equal to 1 over x to the positive 5. If, by chance, I had 1 over x to the -5, well, it's the reciprocal. It's going to take it from where it is, and it's going to move it over to here and become x to the 5 over 1. So the negative exponents just take things and kind of flip and negate them, and not negate them, but flip them. It has nothing to do with being negative. So if I look at this problem right here, I've got w to the -5 here. Well, that's going to come down to the bottom, w to the positive 5. And this w to the -9, that's going up, making it w to the 9. Oh, we're going to talk about this 1/2 in a second, because everybody forgets about the 1/2. Oh, got to quit smoking. Should be pretty easy. I don't smoke. Oh, might get that out. Ooh. Loving math. It's just so much fun. When you have the same base and you're dividing, you just subtract off. Or you could just say 5 of these, we'll get rid of 5 of those and leave me w to the 4th. Okay, so w to the 4th. So what does this 1/2 exponent mean? You have to remember this. It is not something somebody's going to give you and you're not going to be able to find it. It's something you have to commit to memory. 1/2 really means a square, I don't have to put a 2 there, root. So really what we're doing is taking the square root of w to the 4th, and that's w squared. Now, having done all this crazy math and gone all this crazy talk, let's talk about test-taking strategies. Let's talk about test-taking strategy. No work, none, don't have to know any of that stuff. Let's talk about it. Let's take 5, never 1 or 0, and stow it into W. I don't know why I hit a space, enter. Now, my original problem was control division. Nope, should have started with parentheses. Parentheses, control division, W raised to the -5 over W raised to the -9 raised to the control division 1 over 2. That was our original problem. That's what I was given. This crazy thing. I love this calculator. How cool is that? And I hit enter. Oh, and I get 25. That's craziness. Crazy. Now, if I go back and look at my answer was W squared, right? Isn't W squared 25? Boom, done. Use the calculator. It will help you. All right, here we go. Oh, here we go. Not gonna let me do this again. Damn it. Doggone it. Shoot, poopies. Sorry, kids. A little cursing there. Stupid computer. Sometimes it acts up on me. Okay. The principal would like to assemble a committee of 8 students from 15 members. Student councils. Okay, so if we're talking about groups, committees, teams, where it doesn't matter how you pick the people, it's just this group of people right here. This person, this person, this person, this person, and that person. It doesn't matter how you pick them. Then you're talking about combinations, and you have quite a few fewer combinations and permutations. It's not going to be these two humongous numbers. What we have here is 15 people, and we're going to choose 8 of them. Now that's the nomenclature here. On the calculator, you just got to do things a little bit differently. You go into menu, you go into probability, combinations. In this case, it wants you to pick 15, 8. In your 84s, you have to put the 15 first, then this combinations, and then 8. And the answer is 6435. Very simple. There it is. You have to understand, though, that when you're talking about groups, committees, or teams, where order does not matter, you're using combinations, not permutations. An amateur bowler calculates his bowling average for the season. If the data are normally distributed, about how many of his 50 games were within 1 standard deviation? Well, let's go over to the formula sheet, because you have to remember how to use this. And we'll go down. 1 standard deviation to the left, and 1 standard deviation to the right. That's 15, 19.1. That's all to the left, 1 standard deviation. 19.1 and 15 is 1 standard deviation to the right. That is 68.2%. So what I want to do is I want to take his 50 games, and I want to know with 1 standard deviation, I'm going to multiply by 68.2%. Well, that's 0.682. So I go over to my calculator. I take 50, and I multiply by 0.682. It tells me 34 games. So about 34 games. There it is. All right, what do we got here? Last problem for this first section of August 2000 and whatever I'm on. What am I on? 2010. Let's see. We're going up by 2. We're going up by 2. We're going up by 2. So it looks like we're adding 2 to every time. It is not a geometric sequence. So we're not going to be multiplying, we're going to be adding. So let's say b sub n is equal to, we start with 10 and we're going to add 2 to the n minus 1. So when b of 1 is equal to 10 plus 2 times 1 minus 1, that just goes away and gives me 10. They don't have that. Shoot. So I got to find something else. As a matter of fact, wait a second. They have a 10 and they got a 2n. But that doesn't give me this first answer. So I'm thinking it's probably this one. But let's just check. Let's make sure. We're going to do 8 plus b. So b to the 1 is equal to 8 plus 2 times 1. That's 10. Well, let's try b to the 2. b to the 2 is equal to 8 plus 2 times 2. That would be 12. Ah, there it is. We got it. And therein is the last problem, August 2010, part 1, 1 through 14. Hopefully in the show notes there'll be the link to the next section of this, and we'll get going on those in just a few minutes, or I'll get those up as soon as possible. Hopefully they're up. Do not copy cheat. Just work, guys. Work. This test isn't that difficult. You practice, you'll be fine. Actually, if you practice and you use a lot of my videos, email me. Let me know that you kick butt on the Trig Regents. You get 100, I'm going to be like putting your name up on my, I'll put a name up somewhere for you. I'll put all the kids that worked on used my videos. They got 100. I'm going to put your names up someplace. I don't care what school you went to. I'm excited to hear from you. Just so you know, I've never had a student get 100 in 20 years. Had a lot of 99s. It takes a crazy mind to get 100. Now, a little bit of note for you. I've done all 12 of these Regents exams. I have yet to get 100 on any one of them. Not one of them. I forgot a decimal. I forgot to multiply by a half. Every one of them I got a 99 on. Because I just forget one tiny thing every time. It was really ridiculous. And I tried really hard to get 100. But anyway, if you like what you see, hit the subscribe button. Trying to get to 500 subscribers. Peace out. Keep working hard. Don't give up. Never surrender. Bye.